Ladies and gentlemen, water pollution is a severe problem in India, with biological, toxic, chemical, and inorganic pollutants contaminating about 70% of surface water resources. These resources are deemed dangerous for human consumption, as well as other uses, such as irrigation and industrial demands in many situations. This demonstrates how poor water quality contributes to water shortage by limiting its availability for both human and environmental use. One of the main contributors of this issue is the textile dyeing industry, which causes severe damage by the discharge of untreated effluents into the water bodies. Our team is here today to change that. With our business plan proposal, we'll provide a solution to this major environmental concern in India, and we look forward to seeing Hyundai achieve that. And how is that possible? With the use of nanobubble technology. Welcome to the future of the textile industry. Our agenda will consist of introducing our team, executive summary, problem description, product positioning, target customers, alternatives, value proposition, impact, financial reports, entry barriers, implementation, and conclusion. So let's start with introducing the minds behind the development of this business model. I am Nicole. These are Shamini, Eugene Choi, and Eugene Choi. Thank you. So, did you know that to make 1 kilogram of fabric textile, conventional textile dyeing uses anywhere between 25 to 40 gallons of water? To put in perspective, it would take an average person over 2 months to drink this much water. This is our first issue: water waste caused by the textile industry. The second issue we will tackle is the water pollution caused from the textile industry. When it comes to manufacturing clothes, manufacturers use water extensively, and the wastewater full of dye and chemicals negatively affect our environment, ecology, animals, and soil. So how do we propose to fix this? With the use of nanobubble technology to filtrate water and reduce water consumption in the industry, which will be elaborated further on. Our values are economic, as companies will save money and energy by adopting our business model; environmental, as we will directly tackle the water pollution and water waste in India, and as a result, benefit the environment; and social, as the quality of life of the people living in India will be improved.
So let's get more straightforward with our issue here. Textile dyeing is the second largest polluter of water worldwide, and the fashion industry is responsible for 20% of the world's global clean water pollution. Also, textile production uses around 93 billion cubic meters of water annually, which is about 4% of the global freshwater withdrawal. To illustrate this, in order to dye just 1 ton of fabric, about 200 tons of water is required. India is a highly water-scarce region. Around 600 million people, or 43% of India's population, face extreme water stress. That is, 3/4 of India's rural households do not have piped potable water and rely on sources like rivers that pose a serious health risk. In addition, the textile industry in India uses 1 billion cubic meters of water annually, and over 90% of this water ends up as wastewater. Lastly, over 70% of water consumed by rural population in India does not meet the WHO standards. So let us introduce you to the technology of nanobubbles and how this could help combat the problem. Nanobubbles are extremely small gas bubbles, and they have several unique properties, such as strong electric charge, high transfer efficiency, and so forth, which make them very effective in filtration. With that being the case, our product will be effective in 2 applications: reducing water waste and improving wastewater quality. According to research conducted by Interreg Europe, the use of nanobubbles in the garment finishing process has reduced 86% of water consumption. Using this data and the data from the conventional textile dyeing process, the use of nanobubbles will reduce the amount of water being used from 25 to 40 gallons for every 2 pounds of fabric to 3.5 to 5.6 gallons. Also, the use of nanobubbles saves up to 50% of chemical products and almost 97% of wastewater in the process of garment finishing.
So basically, our target customer can be segmented into 2. We have big corporations that outsource to manufacturers in India. They follow the ESG trend and emphasize the environmental factor, looking to make their business more sustainable. Then we have the local textile manufacturing plants that find profit more attractive than operating an environmentally sustainable business. However, as our product is both cost efficient and environmentally friendly, we could approach both target customers. So there are three alternatives against nanobubble technology in wastewater treatment. Firstly, membrane technology, which is basically a barrier that allows certain substances to pass through while blocking others. Second, chemical precipitation. It utilizes the additive of chemicals to make industrial water suitable for use or discharge. Thirdly, biological treatment. This is designed to degrade pollutants dissolved in effluents by the action of microorganisms. So based on these alternatives, we organize the comparison of value proposition. As you can see in this chart, nanobubble technology covers all four factors that we mentioned here: low operating and capital cost, energy efficiency, and effective decolorization. Even though water technologies such as membrane, biological treatment cover some sectors here, we found that nanobubble will be the most efficient and effective technology to improve textile dyeing industry in India.
So how would we make profit from this business model? We're going to rent the generators out to textile dyeing companies. This way, they will not have to purchase the generators that can be very costly and will be able to save water and reduce water pollution. We will be able to rent them out and create revenue by the monthly rent fee. Before I go over the exact cost and revenue, I will go over the background information and assumptions that we made first. We have contacted numerous companies that produce nanobubble generators, and thankfully we're able to receive some information from Human Tech. So this is the model we will be referring to for the calculations later on. Also, since India is one of the biggest countries in the textile dyeing industry, we will be launching our business in India. So all the rates such as water, electricity bills, rent costs, and workers' wages are based off of data of India. The use of nanobubble technology will have a positive impact on the industry environmentally, socially, and economically. We will talk about the environmental impacts first. As we mentioned earlier, conventionally, 25 to 40 gallons of water is used to dye 2 pounds of fabric. But with the use of nanobubbles, we will be able to reduce water use to 3.5 to 5.6 gallons. This means that for every 2 pounds of textile that they dye, they will be able to save 27.95 gallons of water. Not only that, with the use of nanobubbles, water quality will be increased by reducing the amount of chemicals in wastewater. The color associated with textile dyes not only causes aesthetic damage to the water bodies, but also prevents the penetration of light through water, which leads to a reduction in the rate of photosynthesis and dissolved oxygen levels affecting the entire aquatic biota. With nanobubbles, we will be able to improve the ecosystem. These are pictures from a case study done by Nanobubble Technologies. As you can see in the picture on the left, the Nanobubble technology system produced a significant discoloration of the blue dye. The blue dye was monitored throughout 7.15 hours, which yielded 32.7% reduction in COD and 87.9% reduction in color appearance. COD here means chemical oxygen demand and is a measure for water and wastewater quality. On the right picture, it shows how the red dye was trialed for 8 hours and the reduction of COD and color were 52.7% and 99.3% respectively. Therefore, as the waters become clearer in color, there will be an increase in the rates of photosynthesis and dissolved oxygen levels in the water. The waste released from textile industries not only cause water pollution, but also pollutes soil and surface. This causes a number of adverse effects on agricultural products, animals, and health of people living in that area. However, we can reduce the amount of damage being done to the environment with the use of nanobubble technology. The use of nanobubble technology and the positive environmental effects have a positive impact on the society as well. Currently, over 70% of the water consumed by the rural population in India does not meet the WHO standards, contributing to almost 80% of rural illness and 80% deaths amongst children aged up to 5 years old. With the use of nanobubble technology, toxic, mutagenic, and carcinogenic agents will be reduced in water, leading to less diseases and deaths caused by water pollution. And overall, reduced polluted water consumption will lead to a better quality of life with less diseases. Not only is the use of nanobubble technology good for the environment and the society, it can help the industry monetarily as well. In Delhi, the water usage rate is $1.35 per kiloliter. This means that they will save $1.35 for every 15.67 pounds of textile, which is equivalent to a save of 19 cents for every kilogram of textile. Therefore, assuming that a textile dyeing company in Delhi dyes 200 tons of textiles per month, with the use of nanobubble technologies, they will be able to save up to $380,000 monthly with the reduction of water usage. Not only that, as the consumers of the textiles become more and more aware of ethical and sustainable production processes, using nanobubble technology can help the businesses with marketing their brand as one that is eco-friendly. So we're going to start by renting out 200 nanobubble generators to the textile dyeing businesses in India. Assuming that we are renting out 200 generators, our initial cost for the nanobubble generators will be $760,000. Additionally, if we pay 20,000 rupees per worker and hire 15 workers, workers' wages will cost approximately $4,050 per month. Cost of the venue for office and storage would be $3,300 per month and $200 for utilities. If we rent out 200 generators and charge $320 per month, $64,000 of revenue will be generated monthly. This means that we will reach the break-even point in 13 and a half months if we provide 200 generators, and even less if we expand the business farther. We will be able to generate profit of $56,450 per month.
However, there are some entry barriers. First of all, as system design is a bit complex and new, it is hard to let our customer get used to about the way of using this technology and effect. However, in this regard, we would like to support experts to help them learn easier and faster. Secondly, CSR practice. Since there weren't a lot of CSR practice in the past, especially regarding nanobubble technology. However, as a lot of organizations are focusing to increase their CSR now, I think we will solve this problem quickly. Lastly, experimental technology. As we are pioneers, which could represent a challenge. However, it is a good sign that refers that we can lead this market and have a highest market share.
In order to implement this business idea into reality, we should first research the list of businesses that are in the textile dyeing industry and analyze businesses in the market by categorizing them into groups depending on how much they value ethical production process. Next, we'll launch the business in India. We'll focus on the business specifically in India since it's one of the biggest countries in the industry. Next, we'll focus on online marketing before contacting individual businesses so that people and customers are aware of the technology and its effects. After we are done with the online marketing, we will contact the textile manufacturers that are known for their ethical and sustainable operation system. Then we will expand to different businesses in India. As a conclusion, our team strongly believes that with the implementation of the nanobubble technology, we can benefit the Indian textile industry, the environment, and increase the life of quality of the Indian people as a whole. Thank you for listening.
Thank you very much to the team from SolBridge. Okay, you can show your appreciation for them as well. Okay, just going to end your screen share for a moment. Thank you. So again to Mr. Kang, if you have a question, you feel free to ask now.
Wow, thank you for your presentation. That was a huge jump from your preliminary material. I would like to praise you for that first. I'm allowed to ask only a few questions. So I'm just curious, how many nanobubble companies did you approach when coming up with this presentation?
I was able to contact about 20 abroad and 10 in Korea. But we were only able to, we only got answer from that one specific company that we referenced.
Oh, I see. So, but it seemed like you went into the website to study on the subject. Okay, that's my question. Thank you.